Introduction to Distributions. I recently purchased a bag of plain M&Ms, and the M&Ms were in 6 different colors. A quick count showed that there were 55 M&Ms, 17 brown, 18 red, 7 yellow, 7 green, 2 blue, and 4 orange. These counts are shown in the table. This table is called a frequency table, and it describes the distribution of M&M's color frequencies. Not surprisingly, this distribution of frequency is called a frequency distribution. Often a frequency distribution is shown graphically as in this figure. The distribution on the previous slide is the distribution of the M&Ms in one bag. You might be wondering about the distribution of colors for all M&Ms. Conveniently, the manufacturer of M&Ms provides these data. However, they do not tell us the number of M&Ms of each color that they have ever produced. Instead, they report proportions rather than frequencies. This figure shows these proportions. It is called a probability distribution because if you choose an M&M at random, the probability of getting, say, a brown M&M is equal to the proportion of M&Ms that are brown. The data shown here are the times it took one of us to move the mouse over a small target in a series of 20 trials. The times are sorted from lowest to highest. The variable time to respond is a continuous variable. With time measured accurately, to many decimal places, no two response time would ever be the same. For the data in the table, time was measured in milliseconds, thousandths of a second, and no two times were the same. Therefore, a frequency distribution would be quite uninformative. It would consist of 20 times, which with a frequency of 1. The solution to this problem is to create a grouped frequency distribution. The table shows a grouped frequency distribution for these 20 times. The first group shows the frequency for times between 500 and 600 milliseconds. The second between 600 and 700, and so on. There are several rules of thumb for deciding the number of groups to divide the scores into. This issue is covered in detail in the section on histograms. Statisticians have developed mathematical formulas for describing distributions. One you will hear a lot is the bell-shaped or normal distribution. Many naturally occurring phenomena can be approximated very well by a normal distribution. An example of a normal distribution is shown here. The y-axis in the normal distribution represented the probability density. Mathematical distributions such as the normal distribution are called probability density functions. As you can see, the distribution is denser in the middle than the tails. Although this text does not deal with the concept of probability density in any mathematical detail, you should know that 1. The area under the curve is equal to 1. 2. The probability of any exact value of x is 0. And 3. The area between any 2 points on the x-axis is the probability that a number chosen at random will be in that interval. More information on the normal distribution can be found in a later chapter devoted to normal distributions. Distributions have different shapes. They don't all look like the normal distribution. For example, the normal distribution is higher in the middle compared to its 2 tails. Other distributions need not have this feature. There is even variation among the distribution that we call normal. Distributions can also be asymmetric and/or have more than one peak. This figure shows 2 normal distributions. One property of normal distribution is that they are symmetric. If you folded one in the middle, the 2 sides would perfectly match. Although these distributions are both normal, they look quite different. The distribution in red is much more spread out than the distribution in blue. This figure shows the distribution of scores on a psychology test. This distribution is not symmetric. The tail in the positive direction extends further than the tail in the negative direction. The distribution with the longer tail extending to the positive direction is said to have a positive skew. It is also described as skewed to the right. Here we see the salaries of Major League Baseball players in 1974 in thousands of dollars. This distribution has an extreme positive skew. Although less common, some distributions have a negative skew. This figure shows the scores on a 20-point problem on an exam. Each bar represents the frequency of a 2-point range so that the bar on the left shows the number of students scoring 7 or 8, whereas the bar on the far right shows the number of students scoring 19 or 20. Since the tail of the distribution extends to the left, this distribution is negatively skewed and can also be referred to as skewed to the left. This graph shows the frequencies of times between eruption of the Old Faithful geyser. The distributions shown up until now have all had been one distinct high point or peak. This distribution has two distinct peaks, one at 1.75 and one at 4.25. A distribution with two peaks is called a binomial distribution.